In this video, we are seeing at which port we have connected which connection. This LCD, basically the LCD is used in 8-bit mode, and we have connected directly port 2 of the controller to the LCD. Also, LCD has 3 more pins, that is RS, RW and EN. RS stands for register select, EN stands for enable, and RW stands for read or write. Okay, so we directly connected port 3.6 and port 3.7. So port 3.6 is connected to the RS and port 3.7 is connected to the EN, like this. At the back side there are 2 wires. So black wire is connected to the RS. So this is black wire, this black wire is P3.6 and is directly connected to the RS pin, and the another one brown color is P3.7 and it's directly connected to the EN, and RW is directly connected to the ground pin. So this is a ground connection and this is RW pin directly connected to ground. Okay, so this is all about the connection of the LCD. Now we move towards the connection of buzzer. So buzzer has 2 terminals. One is red, another is black. That means red is for positive voltage and black means it's a negative voltage, like ground. So red wire is connected to this yellow wire, and this yellow wire is connected to the VCC. So in this PCB, this side, this side is a VCC and this side is a ground. Also at this position, this side is VCC and this side is ground. We just connected more number of VCC pin and ground pins as to connect the more number of devices if required. So this is one terminal is directly goes to buzzer via VCC and another terminal is to the port pin. So we connected the second terminal of the buzzer is to P3.4. So this green wire is soldered to the black wire. Okay, and when we provide 1 at the P3.4, then the buzzer will be in off condition, as at both terminal we got 5 volt supply. But if we give 0 at the port 3.4, then the buzzer will be in on condition. Then the keypad, that is hex keypad, we connected to the port 1, and at the back side if you monitor there are 4 pins. So exact red wire is for VCC, the another wire, that is orange wire, is for ground, then this brown color wire is P3.0 and black wire is P3.1. So P3.0 and P3.1 is RxD and TxD pin respectively. So this is brown pin is RxD pin. So it means that at this point we have connected it to the TxD, means if fingerprint module reads the data, then it will transmit the data. Okay, so the green color wire is connected to the black wire. Okay, and this black wire is connected at the port 3.1. so port 3.1 is a TxD pin. So this TxD pin and is here, which is RxD pin of module. So RF module receives data from TxD pin of controller, and similarly the RF module transmit data and that will be received by the RxD pin. And another connection is red is for VCC and the black is for ground. Okay, in this way we connected all the circuit. There are another connections like this. So these 2 buttons, so left one is add button and right one is delete button. So we see the connection. So black wire is a ground and this wire, this is a add button. So this wire is connected to the P3.2 and this connected to the P3.3. Okay, so let's look at bluish wire is connected at the P3.3. okay, and the parrot green color wire is connected to the P3.2. It's just a INT0 and INT1 pin of controller. It's basically interrupts. We are using interrupts here. So when I press this button, so it's directly connected to the P3.2, means it's a second interrupt number 1 is generated, and if I press this button, then interrupt 0 will be generated. Interrupt 0 has highest priority, so we given highest priority to delete button, because if you want to delete button, then it should be done very fast and priority must be first. So okay, this is all about the connection. This is DC socket. So black wire is for ground and red wire is for VCC, and we just have to plug the adapter pin. We just have to plug the adapter pin and the whole circuit will be in on condition. So we turn on the supply. So press start key to begin scan. So here start key is there. So if I press start key, then on display we get scan your finger. So if I place my thumb, then scanning successful, searching, finger found, validated ID number 0. So I set default password 1234 for 0th person 0 to 4 up to 8. Means even number represents 1 2 3 4 password, and odd number like 1, if validated 1 or 3 or 5 or 7, it means that the password is 5 4 6 7, 5 6 7 8, and 1 2 3 4 password is for 0th fingerprint, 2nd, 4th, 6th and 8, and odd number is 1 3 5 7 and 9. For these IDs the password is 5 6 7 8. Okay, so let's see. So I have validated ID number is 0, so that's why I press password is 1 2 3 and 4. So on display we get user verified. Again same process is happen. So star, scan your finger, scanning successful, finger found, validated ID number 0. So password must be 1 2 3 4. So but if I press wrong password like 5 6 1 2, then buzzer will be in on condition, and on LCD we get wrong password, and loop continue since from beginning. So if you want to add the fingerprint, then we just have to click the button add. So left side button is for adding and right side button is for removing the fingerprint. So if I press this button add, then it asks at what location we have to store the fingerprint. So we stored the fingerprint at 0th location, and the password of that is 1234. So let's say we store the fingerprint at 9th location, so it's an odd number, so its password is 5 6 7 8. So just press the key, that is 9th key. See, if I press 9th key, then I have to put finger, but I still not put finger, that's why error is there. So I put my finger, and scan successful, storing at location 9, stored at 9. So it's stored at 9th location. Okay, so in order to it's already stored, but for sake of purpose, for we must have to reset the whole system in order to recover the original data. So if I press reset key, then program starts from the beginning. So star key, sorry. So if I press star key, then scan your finger. So I have to press the finger which I stored. Scanning successful, finger found. Validated ID number 9. So the password must be 5678 as it's odd number. So 5, 6, 7 and 8. User verified. If you want to delete the fingerprint, then we can do. So for that purpose we must have to press this button. So right hand side button is for deleting. So it asks location number. So if I enter the 9th location, so 9 button, so location 9 is deleted. Okay, again we have to reset. Reset is required only if we add fingerprint or remove fingerprint. Otherwise there is no requirement of resetting. Okay, so if I do the same, press star key and put the same finger. So at this time finger not found and buzzer is in the on condition. Okay, so in this way we can add or remove the fingerprint. Maximum we can add 10 fingerprint into the module, like 0 location to 9 location. So we go deeper into the circuit. There are 5 diodes here. So these 1, 2, 3, 4, this 4 diode is for pre-rectification, and this is the diode we just have used as to avoid the back current. At the output of this this diode is connected to the filter. So this is the capacitor having value 1000 microfarad. After that, output of this capacitor filter is connected to the regulator. Actually this is a 7805 regulator IC. It's behind the LCD, that's why it's not there. And this is the VCC pin, this is the ground pin, this is the port 0, port 2, port 1, port 3. This is the crystal oscillator having value 11.0592 MHz. These are the 2 capacitors having value 33 picofarad. This is the capacitor most generally used for resetting purpose, and this is the reset switch. This is a variable port by which we can decrease or increase the intensity of the LCD. So in this way whole project working is there. If you have doubt, then you may contact to me. My mobile number is 9145745255. You can visit my website also, www.dnaelectronics.com. Thank you. Thanks a lot.